I'm going to help you answer the back page. So, I mean, it would be nice if you finished and had proof for it. I would probably give your group extra, or give you extra points for it if you kept going. So I know this table already has it done, so they could do the back, keep going, and get extra points from me. But everyone else, like, as long as you have the front and you turn it in today, everything's going to be great. Okay, so they ask about, basically, we were trying to put people in groups different ways. And we put some in groups based on their gender, and we put some in groups based on their grade level, and then we went back and did it a different way. And they said, explain why one group might not be happy with this sampling method. So, thinking about the sampling methods you've been working through in this activity, is there any way you could disappoint a group? And which group would it be?
Not giving them a fair opportunity to represent.
And how would you know that you've done that?
If they have a larger number than the other one.
So, and I think that's basically what I think that question is asking. So if you look at the front page, on the front page of your activity. Yeah. The front page has specific numbers at the very top, like girl, 9th grade, they're 37. Boy, 11th grade, they're 34. So if we added all those up, which I know someone did, who's the one who added them all up? In yours. Thank you. So Samantha added all hers up, and she realized there are 70 9th graders, 75 10th graders, 74 11th, and 71 12th. So she could potentially hurt the 10th graders' feelings because they feel like since they're the highest group, they should have the most people. Or she could potentially hurt girls' feelings overall because there are more girls than boys. So she ought to theoretically have more girls randomly selected than boys. So as long as you argue something like that using the original numbers, it doesn't matter. That's the moral of that story, but it's still okay if you don't get to that. And then basically they suggest maybe the entire thing would be better if we did a stratified random sample. And from each stratified, then choose a simple random sample. So instead of simple random sample of everyone, why not divide them into boys, divide them into girls, and then do a sample? Or divide up into grade levels and then do a sample, which would be smart.
I got something to tell you.
Okay, that's nice. Okay, so the one gender that might not be happy with our method, if we divide up into boys and girls, boys might not be that happy because while there are less of them, there aren't that many less of them. 126 to 164 is not that big of a difference. So boys could be unhappy if we divide up into boys and girls and give girls more opportunity to be on the committee or whatever, the winners. But then, if we did it by grade levels, there is one grade that would be extremely unhappy. One grade level that would be extremely unhappy by gender, because of their gender. Does anyone know which grade level and gender would be the most unhappy?
The
12th grade.
12th grade.
Boys.
Boys. Because there are so few of them. They're going to feel like they're being picked on because when we get to 12th grade, we're only going to select mostly girls because they're really outweighed. So, I think the long story short is no one's ever really going to be that happy. But if we're trying to keep things, and I quote fair, because nothing's really ever fair, but if we're trying to keep things fair, maybe it is better to divide up by gender and then select from that random sample. Or maybe it is better to divide it by grade level and then select from that random sample. It really just depends on what we're going to do in the information. I think for winners, because we're just randomly winning some drawing, it doesn't matter. But if it's like something like, and those people get to report to Dr. Hester and make changes in the school, then it would matter that each grade level is equally represented.
That's my dream.
Okay. Oh, goodness. Okay, so I tried to be cool when we did sampling. And I did cute notes. And I have some more cute notes that we can go back to. But to be honest, I miss just regular notes.
I missed the weekend.
I just like regular notes. So I went back to just regular notes for now. If we want to cute notes that we can, but I'm going back to regular notes for now.
Before I start notes, I'm a little confused on this page because, like,
Which
Can we
one?
put these in our calculator for all the boys and girls and the numbers and like try to do a random?
Kenzie can explain it to you. That's what we like spent like 20 minutes on yesterday. I really want to let you live that nightmare of my life. Okay. Did you get, there were notes in the thing for you?
Yeah, I got.
Okay, perfect. Okay,
You
so,
all started them yesterday already?
no,
No?
no. So we're not even going to start at the beginning. I mean, we're going to glance over it, but not really, because I feel like you already know all this. So you already know what a population is. You already know a census, a sample. It says to plan a sample survey, you must first say what population you want to describe. That's the only thing I might underline. When we say population, we might just mean our school population. Maybe just THS. Like just THS. And then we could state exactly what we want to measure about the students here at THS. Or like just THS students, we could be even more specific. It helps to be specific when you say population. Otherwise, you're kind of implying everybody in the world. So at least you say like the population of the United States or population of high school students in the United States. So we are going to quickly do the examples. They want us to identify the population and the sample in each of the following settings. So what's the population? What's the sample? I'll give you a strip. That way we can get some points for me and Matthew today. The population is what?
High school students of the school, and the sample would be the 100 students they serve.
You're good. Yeah. Okay, so the population, and I'm lazy. So, I might not spell it all out. High school students at whatever the school is. We would pray they'd be more specific. And the sample is the 100 students surveyed. Okay, same issue. We need to know the population and the sample.
Sample would be the 10 cans every hour from the production of this factory, I guess, this company. And then the population would be the total number of cans per week.
Another point.
In that factory.
Add a
That
point.
factory is right.
Jackson, add a point. So I know we're being facetious, but at the same time, you do need to be that specific. It's not just cans produced everywhere, it's cans produced at that factory. 10 cans every hour from production line. In that factory. Okay, and then I'm going to quickly read over things you seriously already know. Convenient sample is when we are just doing people who are easiest to contact, and that's a lazy way. We talked about how that would potentially show bias, and bias is if we're consistently underestimating or consistently overestimating the value of what you want to know. So we would think, hopefully, if our sample is a good representation of the population, we're actually going to find the truth, or we're going to get as close to the truth as possible. But if we're biased, we're getting nowhere near the truth. Okay, voluntary response is when you obligate yourself. And then we talked about sometimes necessary. It's sometimes necessary for someone to obligate themselves with a voluntary response. And we discussed that yesterday. Do you remember why?
You have something that could potentially harm or kill someone.
Yes, so I'm going to put especially with medical studies. And that's what we were talking about yesterday with the different drugs. You kind of have to get someone's. You can't just drug someone for fun. So, Right, so they have to sign a waiver or something before you can start testing on them. So technically, could you, I mean, yes, they signed a waiver saying it was okay, but could you have selected from a larger group to choose those people to ask them? Yes. So was there still some randomization? Yes. But they did technically volunteer as well, so I don't know. Okay, so there's this example about the Los Angeles City Council. They voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The LA Times conducted an online poll that asked if the city council was right to pass a boycott of Arizona. The results show that 96% of the people in the sample said no. Okay, what type of sample did the LA Times use?
Voluntary response.
And that's a problem. Why is that a problem? Question 2 asks why.
Because people who strongly want
feel like respond.
Let's go with that candidate.
It slows us down. I feel like we've said the same things 5 times. Only strong opinions respond. Okay, so you only respond if you feel strongly one way or another. And obviously this leads to bias because we assume residents against law. And so we're assuming the residents are against the law, but we don't actually have proof because, again, these people felt strongly, so of course they said something. So I could use more words. We assumed the residents were against the law, which could taint our results. Could taint our results. And I know we keep hitting the nail in the coffin and going over the same things over and over again, but that's kind of exactly what one would argue happened this last election. They assumed everyone was against Trump. There was no way Trump would win. And so they assumed, they predicted no way Trump could win, and then when he won, they were very, very surprised. So one would argue that they probably had some bias in their survey, or in their sampling method, however they got their sample from their population.
Here's a question.
Yes.
Is there any, sample or whatever, where there's, no bias at all?
Simple random sample.
So we're praying a simple random sample does that, but as we've seen in that last activity, that's not necessarily true because sometimes we feel like, hey, we left off all the 9th grade boys, or hey, we sure did choose a lot of 10th grade girls. So that's why we talk about blind and double blind. So we're hoping, if it's blind and I don't know she gets the drug, he gets placebo, they don't know drug placebo, and then I don't even know drug placebo, the further away I am even from that, then hopefully it's all legit. But is anything ever 100% legit in life?
If people are involved, there's going to be bias.
Yeah, and it's not necessarily intentional, but you can take the results. Okay, so we've already talked about this as well, how to sample well. If you're going to sample well, the least you can do a simple random sample, and we've talked about 3 different ways to do a simple random sample, and those 3 ways were the 3 ways to explain and describe your random sample.
Oh, hat technique.
That's 1.
Random number calculator.
Yes, and the 3rd?
Data table. Number
So
table.
2 to you, 1 to you, points wise.
Okay.
It's the hat, the random number table, and then you can generate it with your calculator. However, as this guy's the random number generator, even though I love it on my calculator, that's not the one they're going to go with because they can't promise they're going to have the same random numbers as you. So that way we all have the same random numbers, which you argue makes them not random, but that we have all the same random numbers. The only way to do that is with the hat, well, not really with the hat method, but with the random numbers in the table. Okay, so we've got this example. There's some company. The management company of a local mall plans to survey a random sample of 3 stores from the 21 listed below to determine the hours they would like to stay open during the holiday season. They ask us to use our textbook. We're not going to do it. You've already had to do this before. I mean, we might, but we'll do it quickly. I wouldn't mind doing it. Okay, so it says starting at line 111. So I go in my textbook to my random digit table. I go to line 111. How many digits am I looking for?
Why is famous footwear?
Why is it 2?
Because it's 21.
Perfect.
We have a question.
Yes, dear.
Famous footwear's on the twice.
Interesting. Maybe they have 2 different locations inside the same store. That would be my only suggestion. Otherwise, you would think it's a typo. So, like, that's their first location, and that's their second location. That's my only thought. You know, I didn't make this. So maybe there's 2 locations in the same mall, which seems stupid, but still nonetheless.
We have a secondary question.
Yes.
Okay, that's right.
Yes. Okay, so I go to line 111, and it says somewhere in a selection of 3 stores. So I'm looking for 2 digits, but my first 2 digits are, you can see, my first 2 digits are 81, so that's not going to work. 48 is too big as well. 66 is too big, 94 is too big, 87 is too big, 60 is too big, 51 is too big, 30 is too big, 92 is too big, 97 is too big. This is why we should have skipped it. 00 is our first option. 41. How many stores are there?
Are we starting at 1 or are we
starting at 1 or
starting
20?
at 0?
Are we starting at 1 or are we starting at 0?
I think 1.
There are 27 stores, so 00 doesn't even count. So my gosh.
Solution, don't use this.
So let's not do it. But regardless, we're gonna get some random numbers. Woohoo! Great. But I do want to do step 2. Describe how you would use the names in a hat.
Just put all the names in a hat and you pull one out.
Yeah.
And you pull another out.
Okay, I'm gonna say put all store names in a hat.
Remove one and do not add back in, and then remove another.
You could just pull 3 at one time. I mean, it's less random, but I mean,
Remove.
What's this choose 2?
I thought it was 3.
It says 3.
Oh, I thought
But-
I was confused because of 2 and then 21.
I kind of like the way, I'm going to go with the way Jackson said it because I like that he, in his explanation, so remove slip, do not replace, and could I add more words? Absolutely. Am I out of space? Of course I am.
Repeat.
Do not replace. Repeat twice. I'm sure that there are better words, more words, but what we're focusing on is the fact that you put them all in a hat, everyone has equal chance, and the do not replace. You've got to address if there's duplicates, which is why Sally was asking about 2 famous footwear. So that's why I put famous footwear 1 and famous footwear 2 to try to alleviate that. And if that really happened on the test, Lord, I pray you label the 2 different famous footwears, but they would not do that to you. Okay, and then the last thing we need to do is describe using your calculator. How would you choose a simple random sample of 3 stores?
You have to number the stores, like,
1 to 21.
yeah.
Okay, so number stores,
And then,
And then you hit random integer.
1 to 21.
Math random integer.
Use calculator
Rand, integer.
feature,
Integer. I think it's integer, actually.
It's
rand, int.
Randy.
Yeah.
Randon.
And
Randons.
then, you're gonna want 1,
to 21.
comma, 21, comma, and 3.
Okay, and then you should probably explain that and say,
The range is 1 to 21.
yeah, range
And then 3 is how many you
1
want.
to 21 stores. And then that's the number we want to select. Number we select.
Duplicate, however, it doesn't say describe, it says find them.
Okay, and then I would like for it to say, well, I'm still describing. I understand. I still just want to know you can describe. I know you can find. Everyone can press the buttons. Woohoo. Okay, and that's what Sally was addressing, is that, or I thought she was going to address, or I thought she was addressing. I don't know. I'm making it up in my head as I go. The repeats. We haven't addressed repeats.
Ignore them.
Discard or ignore repeats.
Discard.
I think discard sounds fancier, so I like it. Ignore repeats, just discard repeats. If you can't spell discard, you need to use ignore.
Discard.
Okay. So basically what we're doing when we talk about ignoring repeats or do not replace, we're making sure that we pay attention to our sample that we're saying specifically we are not replacing these numbers. Okay, and then you've got to be careful. So we didn't do a good job with the random digits table. I didn't write it down well. So you and I both know we were looking for 0, 1 up to 21 in our list. And if we saw 0, 1 twice, we were going to ignore duplicates. So somehow we need to explain that better. So like maybe assign stores, assign numbers 0, 1 to 21 to each store. Use table to select 3, ignoring duplicates.
Are you explaining this for our benefit or because this is what the problem is wanting?
Your benefit, because really the problem is wanting us to come up with random numbers each time. But I feel like you've done so many, like even just yesterday, you already did a random number table. You already did the random numbers in your calculator, and the hat thing's just as stupid. So pricing, again, not so good. Pricing how to use our words with it, much, much better. Okay, finally we're going to get to the part that actually feels like not new information, but at least not the same old information. Okay, so it might be good to do, instead of a simple random sample, it might be better to do a stratified random. The way we were talking about, maybe it's better to consider gender first or consider grade level first. So it might be good to put people into groups of similar individuals called strata. So your group is your strata, and our examples that we keep going back to are gender, grade level. And then we can, from that strata, select our simple random sample. So we could say, out of the freshmen, we're going to select 10. Out of the sophomores, we're going to select 15. Or whatever it is we're going to do. And that might be better. It just, again, it depends on what we're going to do with this experiment. So we're tired of sampling people. Like, what are we going to do with this information? And that determines how we would sample most of the time. And then this is the word that you're mad at because you feel like we haven't talked about before. So I'm glad it's finally appeared. Take a cluster sample. We divide the population into smaller groups called clusters. Ideally, each cluster should mirror the characteristics of the population. So, for instance, if we were going to cluster in this room, if we have 1, 2, 3. Yeah, I guess each table looks like a cluster, but not really, because this table has 2 girls, this table has 3, that table has 2. So we would theoretically in a cluster want like 2 girls, 2 boys.
So the characteristic.
Yes. So we would like, yeah, so we don't technically have the perfect clusters.
You can split it into 3.
We don't have ideal clusters or whatever in this room at this exact time. But maybe we could do each cluster should mirror the characteristics of the population. So if we have a population with a lot of Hispanic people, then we need to have a lot of Hispanic people in each of our clusters. Like, it just depends on what our population is. So clustering sounds great. It's only really necessary if you've got a really large population. Otherwise, clustering just seems kind of silly. Okay, so example 4. You might want to take a survey of students from your high school. You want to take one. Describe how you use each of the following sample methods to select 100 students to complete the survey. So a simple random sample, we're going to get a list of everyone's name. And we're going to, so list of names. Random. Number, yeah, I mean I should, but I'm not going to because I should say randomly assign numbers. Yes, list of names, randomly number each student. Use number each student. Number each student. No, I agree. Number each student. Use random number generator to select 100. Have another point for that. And I know it feels like we're being redundant, but maybe if we say it enough, like when it needs to come out in life, it will. Okay, if we wanted to do a stratified random sample, what should we do?
Well,
Break it down to gender and grade level.
always grade level, yeah.
Let's do list of names. So I'm going to say list of names by grade level because they can produce that.
Do you have some rules in this? Like, how many people are in each grade, or would you have it equal, like 10 from each, whatever? 10,
I'm super lazy, so I'm going to say 25. Use random number generator to select 25 names from each group, from each grade level. So use random number.
Should you list anywhere in your description that when you describe your repeats, you need an example or something? Because you still need to have 100.
So maybe I should say discard repeats.
Discard and
But-
redraw repeats.
Yes, discard and redraw. I like that. And redraw. Good phrasing. Absolutely. Absolutely. English. List of names by grade level. Use random number generator to select 25 names from each grade. And then I'm literally super lazy at the moment, so I'm going to put that exact sentence and say bring it below. Discard and redraw for repeats. He makes a good point, which Kenzie made the last time we talked about this. Grade levels aren't equal. There are probably less seniors than freshmen and sophomores. It probably should give 30 freshmen versus like 20 seniors. I get that, but weren't given the specifics of this population. So when in doubt, just divide evenly into 4. Okay, cluster sample. How can we do a cluster sample?
Do like
Yeah, cluster.
divide it by grade level and boys and girls? Like,
Yeah. In that case, you would have it proportionate as far as like gender-wise, right? You just do it-
Yeah, so maybe we want to cluster. Each cluster contains so many freshmen, sophomores, juniors, seniors, girls, girls and boys.
Maybe not like the grade level, but
That's so
definitely I think like the
complicated.
gender, I think.
You basically have to make each cluster have the same percentages as the
Yeah.
entire population.
So if we've got 60% boys, 40% girls, then we need 6 boys, 4 girls, and 10 clusters.
Yes.
So, I mean, we're making this up as we go, so why not do it that way? It's because, I'm not spelling it out because I'm out of room, because population, and I need to throw this bit away. Because population here is 60% boys and 40% girls. Divide population into groups with 10 members, 6 boys, and 4 girls. But then from there, we're still repeating the same thing. We're still using a random number generator to select, let's say, 1 name per each of these clusters, or like 2 names per each of these clusters. Depends on how many clusters we have. Depends on how big the population is.
Could we say that?
So would it be 10 clusters or would it be however many?
I mean, it's going to be however many kids we have. So if we have 1,000 kids and we do 10 clusters, then that's 100 kids per cluster, which is great. But we would still need to know the total to know how to divide it up evenly. Yes, dear.
Could we say that each cluster must be proportional to the population?
Maybe just saying that would be just best. Maybe instead of being even this specific, maybe Jackson's right and let's just go generic. Each cluster must be proportional to student population. I like that. But I still just think cluster is unnecessary, but I don't
I kind
know.
of like the idea of having a proportion between the genders, that way they feel equal.
I like that part, but I felt like a stratified could give us that. But I like that the cluster is representative of the entire population, but I just feel like the cluster requires a lot more work.
Yeah, I mean,
And I'm
if you were
lazy.
to create a proportion between stratified between the different strata, wouldn't that make it a cluster sample at that point?
Mm-hmm.
So then it's still a cluster.
Mm-hmm.
Do a cluster sample with the grades, like if there were less seniors, we would do.
We could do clusters with the grades, so if there are, proportionally 10% seniors, and then we have 10 in our group, then we only need one of those people to be a senior. Like, I agree, but again, this is all hypothetical. We still need to be told total population, at least percentages of grade levels. We're going to need a little more information before we start, saying, hey, Louise, you're in group 2, you're in cluster 2, and Sally, you're in cluster 5. We're going to need a little more information. Okay, let's go to the next thing. We're so close to being done with sampling. I'm determined to stop talking about sampling. Okay, so if we make our sample, we're hoping to make some sort of inference from our sample. We're hoping to learn something. So if we're trying to learn something from our sample data, it's called an inference because we're trying to infer information about the population from what we know about the sample. So if we've done a good survey or whatever, and we found out that our sample said that everybody loves ice cream, then we would assume everyone in the entire student population loves ice cream. We're hoping whatever we learn can be applied to the entire population. We're making an inference. Okay, but if we made a bad sample, then what we're assuming is going to be crap. It's going to be biased. So we're trying to reduce the bias in our samples. And another reason we prefer random sampling is that has to do with our next chapter, which is probability. Because, let's face it, if we are choosing the sample, we're going to assume we did things the way we wanted to, and we led the numbers the way we did. So how can we assume percentages and stuff like probability? And also, even though random samples are awesome, we realize there's always in life a margin of error because we are human and we are the ones conducting this. So there's always a margin of error because just because we sampled this group today and it said this, if we sampled a similar group a different day, then we might get different results. We're still dealing with people. And when people are involved in an experiment, what are they called?
Subject.
Okay.
Sorry. That's an example.
Okay, so basically the bottom line is the bigger our sample, the better information we can guess about the population than a smaller sample. But you and I both know the bigger the sample, the more work we have to do, the more money that's going to require. So sometimes it's not possible. Okay, so sampling errors. What can go wrong while we sample? So we've already talked about voluntary response, which is when, we already talked about that. Moving on. Under coverage. We leave some groups out of the process of choosing the sample. I feel like the census has some under coverage because there's this whole group of people who aren't registered, so therefore they're not involved in the census. So I feel like the Hispanic population has under coverage. Okay, a sampling frame is the list of individuals from the population which we draw our samples. Okay, so if we were doing at the school, all the kids here, our sampling frame would be the list of students at the school. But, school is a much smaller number than everyone in the United States. So it's really hard to get a list of the entire population, of a real population, not a school population, but for reals, like the entire United States. For reals. Okay, non-sampling errors. So, some people refuse to respond. So the non-response people might throw up our data. And then, I don't know about you, but I am occasionally bad at when someone hands me a survey and I'm supposed to fill it out. I might not really read it. I might just mark things. Yep. Have you never just done that, made a pattern?
Yeah.
Or you're just like, I don't strongly agree or strongly disagree. I'm just in the middle, and I just mark in the middle on about everything in life. I'm just neutral. I don't know. I don't really care why I'm having to do this. So that could potentially be an issue. So you could intentionally or unintentionally lie. Or you could, in the way you ask the question, influence the person negatively. Okay, moving on. So there's some source of error in these examples. We need to determine if it's sampling error, non-sampling error, and explain our answers. So the telephone directory is used as a sampling frame. Sampling error, non-sampling error. Okay, so look at what we just talked about. Sampling errors include, because that's our bad, voluntary response under coverage. Non-sampling errors, that's the person we asked bad. They didn't respond, or they did a terrible job. Response bias. Okay, so the telephone is used as a sampling frame. Is that a sampling error or a non-sampling error? Was it our fault or is the person who responds fault?
They're our fault.
If we design a survey and we're picking people from the phone book, it's our fault because not everyone is in the phone book anymore. And not everyone, even if they are in the phone book, answers the phone. Okay, you tried contacting a person because for your survey, and you didn't just try once, you've tried 5 times. Is it your fault or their fault?
Their fault.
So I'm going to call that non-sampling error because they have no response. And then the other one was due to undercoverage. And then the interviewers choose people walking by on the sidewalk to interview. We know that's a convenience sample, and so it's our fault, so it's sampling error. She does. And it is convenience. But it also has voluntary response. I'm really hoping someone will argue something else. If someone stops you, it is under coverage, I agree. But if someone stops you walking down the sidewalk and dares to ask you a question, are you going to tell them the truth? No, so I think there is some non-sampling error with a response bias. So I think there's a response bias as well, because I'm not going to tell that person the truth. Okay, so that's just my 2 cents. I think there's also response bias. But one can argue lots of things in stats. A survey paid for by makers or disposable divers. I don't know. I just thought it was funny. Okay. A survey. So the makers of the disposable diapers did a survey, and they found that 84% of the sample opposed banning the disposable diapers. I'm sorry. Here is the actual question. You gotta admit disposable diapers is a funny term. Okay.
Tell yourself, I'm the disposable diapers.
Okay, so. But they paid to have it done, so they didn't actually have it done. So I know I agree. I would have thought the same thing, but no, they paid for an outside company to handle this for them. But
they worded that.
That's the. Okay, so let's read the wording. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class milk, and yard waste are estimated to account for about 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? And then explain how the wording of the question could result in bias. And then be sure to specify the direction of the bias.
It's obviously biased towards not banning it because they're giving all this bad information about other stuff, and they're giving good information about
I agree with that. No, I agree with that. I agree with the 21% and the 2%. That they're arguing that clearly this other junk is way worse than our disposable diapers. I agree with that.
It might be partly because the 21% is made up of 4 different things, acronyms in one.
Okay, so the question, Kinsey said, how to phrase it. Question implies, I don't think you can, that's why I was laughing. Disposable diapers not near as large of a percentage of the trash in landfills as other items, and I used a lot of words as other items. So I agree. The way they worded the in question was like, how dare you ban my disposable diaper? It's not taking up much of the landfill at all.
Strange thing to want to ban.
I agree. But the last thing says specify the direction of the bias.
There's disposable diapers and like you want it.
So it's definitely so pro disposable.
Wait, no curtain. Let's cut curtain.
Now I was laughing because it's funny. I don't know. Someone's waving at me apparently.
There's someone there.
Okay, so that's nice. I mean, I don't know. I'm still going. Okay, so I don't know. So moving on with my life. Thank you, dear. I'm gonna keep doing math now. Okay, so I think that it's funny because I'm with you. I don't see how you could ban disposable diapers because people who wear them are little babies, or eventually all of us get old enough and lose bladder control. So I just don't. I don't feasibly see a ban on disposable diapers. I don't know.
Non-disposable diaper.
The non-disposable, which means you would have to do cloth, which is why Olivia was saying, I'm not going to do cloth, I'm going to use disposable.
Why would you want to?
Imagine.
I don't know.
Imagine being mom.
I don't know. Okay, so my goal is to get to example 1 because finally, my gosh, we get to use the word experiment and nothing about survey. Okay, so you kind of hurt my heart a little bit, just a little bit, when some people who will not be named, but they know they didn't, they got observational study and experiment confused. Again, an observational study imposes a treatment. If we're going to give you some sort of drug or literally do something to influence you.
You just said observational study.
Oh, sorry, all words came out wrong. Experiment imposes a treatment. Observational study, it sounds like observation. We're going to observe you. Observational study. We sit there and we observe you. We don't actually try to influence you. We just watch your behavior.
The effects of the treatment.
If we're observing the effects of if there's a treatment, it's an experiment. So my treatment goes to experiment every single time. Okay, so a lurking variable, we talked about how it could still be affecting things and it may influence the response variable. We've talked about confounding. Okay, if you're giving a specific, like the specific condition applied, so let's say we're giving them a specific drug or whatever. So in my example is a drug. Or we're giving them a specific job to do or whatever it is that we're doing, that's the treatment. So it doesn't have to be a drug. We could just make everybody sit here like an extra 5 minutes or whatever. It doesn't have to be a drug. It could be a time thing. It could be lots of other things. But whatever we're making them do that's special, that's the treatment. And if there are several explanatory variables or factors, a treatment is a combination of specific values or levels of these variables. So we were discussing how it wouldn't be fair if Alex has a heart condition for me to take his medicine away from him. I might give Sally the newer brand and he still gets his old brand. But I'm not going to say, Alex, no medicine for you. So that would be a different level with the new meds versus the old meds.
We want to see the effects of the drugs. That'd be the best way.
Yes.
Is that worksheet going to be used?
No. Okay, so we're called subjects if we're the experimental units. I think that's about it, although I am going to tell you a funny story when we pack up. So when I was I'm going to stop recording on that. When I was at UA,